Hello, and thank you for joining us for the Object Storage for Media and Entertainment plus Content Delivery webinar. Before we begin, I just want to get some housekeeping items off the table. Feel free to ask questions throughout the webinar. This will be a very informal conversational webinar, and we encourage you to ask questions throughout. If for some reason we do not answer your questions while we're presenting, we'll follow up with you shortly after the webinar and respond and answer your questions via email. We will be doing some polling questions throughout. Again, we appreciate your participating in the polling questions. We only have 2, and we have put some attachments and links for you as follow-up reference materials. We have a great solutions brief there, and also a Chalk Talk video that you can view after the webinar. But with that, let's go ahead and get started with some introductions. My name is Adrian Herrera. I'm the VP of Marketing at Caringo. But from a background perspective, I have a pretty strong media and entertainment background. I've been part of organizations that have both been on the encoding side of video and audio all the way through content delivery and user-generated storage sites. So I have a lot of knowledge from the front-end perspective of this topic. And with me, I have Ryan Meek. Ryan, you want to introduce yourself?
Yeah, hi everyone. Thanks for joining us today. I'm Ryan Meek, and I'm a product manager at Caringo. I also have been with the company for some time, and I've done testing as well as development, as well as working with customers in the field, setting up content delivery and setting up media and entertainment. So I am speaking from firsthand experience in many cases here. Very happy to join today.
Yeah, I think Ryan has some great experience. He's been involved in pretty much most of our media and entertainment deployments at Caringo. So he'll be sharing some really solid information based upon what we've seen in the field. And we have a lot of companies using us in the media and entertainment industry, and also for content delivery and content distribution. But from a high level, Ryan, why don't you walk people through this slide?
Okay, so object storage is actually a great platform for media and entertainment. Not only is it sort of well positioned handling petabytes of content, it's also very fast by design. Handling content at scale is something that's addressed from the very beginning in the actual architectures of object storage. So as these models grow and as user-generated content sites grow, for instance, the storage infrastructure and the content delivery infrastructure can grow right along with it. We see that everything from the primary storage of the first release of a website to replacing legacy content delivery systems in place and at runtime. It's ideal for quite a few different reasons that we're going to get into more detail with. But I think the main takeaway is going to be having HTTP on the front end and being built for speed and built for scale is exactly what you want in these systems. Adrian, do you want to talk a little bit about sort of monetizing and long tail content really in the web space and in the content delivery space?
Yeah, definitely. Being on the front end side of infrastructure before delivering media services, I know that latency is of paramount importance, especially when you're dealing with freemium and ad-based services, and there's a lot of them out there. If a user does not see their content or the content they're trying to access right away, then they're just going to go to another service. So, for instance, we're used on a lot of dating sites. If you can't view the thumbnails or the photos on your dating site, or the other site you're surfing on or you're trying to access, it just leads to a poor user experience, and those users will go somewhere else. But the second part of that is, being economical. So you need something, you need the perfect mix of price and performance, something that is low latency over the web, delivers a great user experience, but also economical. You just can't use traditional storage devices because they're frankly too expensive to support in an ad-based or freemium model. So, what we'll talk about and what we'll cover in this webinar is, the whole world of media, entertainment, and content delivery use cases, and we'll give kind of high-level approaches and go into a high-level overview on why object storage is ideal for these. And now, arguably, that's still a pretty broad topic, and if you do want us to drive down into any one particular use case within M&E and content delivery and content distribution, we can certainly do that. But with that, Ryan, how about we walk people through, why object storage is great for media, entertainment, content delivery, and content distribution.
Great. So let's get right into the weeds right up front and talk a little bit of tech here. So web traffic, content delivery is generally web traffic. Web traffic, the protocol is HTTP. Now, object storage and swarm storage in particular was purpose-built for HTTP, and the storage backend is actually highly optimized for HTTP. So the object container, and this is going into a little bit of an intro to object storage for anyone who's not fully familiar with the space, but we'll go through the intro pretty quickly. So objects themselves are made up of metadata and data. And so if you think of HTTP at the protocol level, the actual container is generally a MIME. It's basically a MIME message. And the format of that container is something like header, 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 header data. So you have HTTP, it's coming in as header, 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 header data, and the actual object storage container for the object is also header, header, header data. So this is a really key point because no protocol changes are necessary between the front end and the back end, and you can just think of it as a really high-speed, high-performance pass-through. And it's a pass-through to the point that it's an actual web server. So you can really think of it as a web server on the back end, and it honors parts of HTTP that are key for existing in a modern infrastructure. So things like HTTP range reads let you seek into the middle of a video or right into the middle of a file. And this is really important. If you have users that are looking at videos and they're grabbing progress bars and they're pausing and they're moving it around, they're seeking out to 3/4 of the way through the file, you don't want a legacy file system infrastructure behavior like, oh, okay, well, a user touched this file, so now we have to load a 40 gigabyte file into some kind of upfront cache. This is actually going to serve the bits that are requested, even if they're from the middle of the file, and they aren't going to be triggering large file movements on the back end that are unnecessary. It's also built for many users and many parallel sessions, just because that's how the web works. And the web works in these ways really for high availability and resiliency. So these requests, they aren't like a local file system where it's mounted to a web server, and if that mount goes away, the web server's stranded and can't find the content. I mean, these requests can be routed to different servers on the site. They can be routed to different racks on a site. They can even be routed from different locations. And what's important to the user is that all the requests get serviced. So at a really high level, you have, go ahead, Adrian.
Oh yeah, and that's an important point, kind of the ambiguity in use cases. And just to kind of supplement this with a little bit of how analysts see the market, Gartner defines this as mode 2 applications. You know, your mode 1 applications were more of your static applications, your ERP, your standard typical traditional enterprise applications. You know, for those, you're able to really forecast what your use is going to be, what your storage utilization is going to be, you know, how many concurrent users you're going to have. It's very easy to predict. In mode 2 applications, your web, your mobile, your social, it's very difficult to predict how many requests you're going to have and really how much storage you're going to need and access you're going to need, you know, what, you know, bandwidth requirements are. And that's kind of at the heart of why object storage is ideal for these use cases.
Yeah, I think that's a great point, and I think I would even add that as you have user-generated content that's piling up, you know, in many cases it's piling up for years. So, you know, you need an infrastructure that not only can it scale, you know, overnight or over a week if your traffic goes up by an order of magnitude, or if it needs to scale that way, but it will actually do things like verify integrity of videos and files long term, and it will do it in a way that's very precise, that it knows really, even to a compliance level, that this was the file and this was the data that was stored when it was stored originally, and it hasn't either decayed or it hasn't been tampered with. So that can be especially important, you know, for different use cases. But to do it in a way that's purpose-built for retention, performance, high availability, all at the same time, those are all characteristics that are right in the sort of object storage and swarm wheelhouse.
Yeah, and before we do a deep dive into kind of a before and after scenario, I'm going to go ahead and push out our first question. It's really to help us target, you know, what we talk about and what we present moving forward. Because as I mentioned, we do have a broad set of use cases in the object storage world for media entertainment content delivery. And the question is, what type of content do you store? Photos, video, audio? We don't deliver content yet, or other. We have use cases for all of these, except maybe we don't deliver content yet. Everyone using our software object storage is delivering some type of content and storing some type of content. But we'll go ahead and leave the voting up, and what you respond to or how you respond will help us go ahead and target the rest of the presentation moving forward. But with that, Ryan, you know, why don't you walk people through the before and after scenario from an object storage perspective?
So this is really what we've seen in the market, and it's such a common pattern that, you know, it could almost be understood as patterns and anti-patterns for architectures. And what we've seen is many cases where either the applications exist or, you know, they're in the process of being written. They, in many cases, had a relational database issue where the load on the database just simply couldn't keep up with the load on the front end. And when you go and look at the actual before architecture, you know, you see that there were layers of databases, layers of file systems, and really, you know, SQL that needed to come back to give access to, in many cases, even things like thumbnails. So these things need to be loaded very quickly, and actually getting bits out of a database was just simply not going to scale. Really, even looking for a location for resources that are coming in, like a resource request coming into a web server, then a web server talking to a database, looking for a location on a legacy file system, going and finding the file, and then returning, you know, that's really an anti-pattern at this point. That is the before architecture, and you can see it really clearly on the left-hand side here. The key takeaway here is with Swarm, okay, this actually eliminates or unifies the web tier and the file tier, and it lets the incoming requests be forwarded directly to the storage with no taking the request apart, querying of the database, looking for a legacy file system, looking for a share on a network. The request is actually more or less a pass-through. Encoders or video on-demand servers can access the swarm content directly because it's a well-behaved member of an HTTP infrastructure, implementing HTTP 1.1, and really having all of the mechanisms in place to interact with things like content delivery networks, CDNs, your Akamais, your Limelights. In many cases, this is feeding web traffic, but it's also feeding CDNs. It's especially important too that CDN can do things like, check and see if there's new versions of that content that's in the object storage without going and having to pull every file. So honoring things like cache coherency headers directly out of the storage mean that these things don't have to go and pull every file in your infrastructure in order to know that they have the correct and complete set. I think another thing to notice here in the after side with Swarm is, in addition to being simple, easier to maintain, having sort of a lower total cost of ownership, in many cases there are still databases back there in the applications, but as long as they're not in the request process flow, or as long as they're not tightly bound to the extent that they interrupt and limit the performance or responsiveness of the sites, that's just fine. So
Ryan, as far as complexity, we've dealt with a lot of customers and come in and made this kind of consolidation or flattening of the IT stack. What are the benefits there? It goes beyond the benefits, but how about the latency gains? What have we seen in the field from a latency perspective?
Yeah, I mean, when it's really melting down, of course, we've seen over a second of latency. It's really common to see, thousands of milliseconds, hundreds of milliseconds, come right down to single-digit milliseconds. So really, anytime you can put order of magnitude or 2 orders of magnitude improvements on latency, it really matters. There might be a web page there where tens or hundreds of thumbnails need to load. Many times they're loading in a serialized way, and so it really matters to the user experience. It also matters just to the back end operation and load on the database for the IT staff and the DBAs not to have that kind of pressure building up on the database and file system levels.
Yeah, and I would add to that it's also the protection of or the administration of the database. So that's one issue that we've heard a few different times, that it wasn't so much a load on the database. It was these organizations are struggling on how to replicate and protect their databases.
Yeah, absolutely,
sure that,
especially
they remain online.
Absolutely, especially when you're talking to then about hundreds of millions of pieces of content being added, or user-generated content, or things like ad clicking and associated metrics. It's really quite a bit to have in one centralized place, and it's much easier to manage, much better sort of total cost of ownership if it's flattened out and scalable in one layer.
And we see, you went over this briefly, but web server, VOD server, caching proxy. Can you give some examples of caching proxies that we work with, and other technologies that we work with?
Yeah, so Varnish, Squid, Nginx, F5, Big IP. I mean, I think those are from smallest to largest. It's anytime you hear, it's really common to have those pieces of infrastructure on the front end of these sites. And we work really seamlessly with them through being good HTTP citizens.
Yep, great. You know, I guess we can do a deeper dive into kind of the media entertainment content delivery workflows. You've touched upon a lot of this already, but you know, I guess can you walk everyone through this diagram?
Yeah. So I think the big takeaway here is just it's not a storage silo that only a web server and a database and one application needs to talk to. And so it's a real good citizen on the back end with many different layers. So you'll have a CDN that might be talking to the front end, and we've talked about that a little bit. But you also have users. You also have users using content on mobile devices. You have responsive designs out there. You have different screens, different formats. They can be desktop, web, different browsers. That is all sort of pushed into HTTP traffic, and it will get it'll get interpreted by video on demand servers, web servers, and that content will be translated. But the big thing there is just handling requests really quickly and accurately, and being able to route requests to the right sites. Now on the back end, say in a content workflow, you know, on the back end of the house, you'll have things like asset management. So you might have content being directly ripped or, you know, directly digitized. You know, we've worked with people very specifically that are digitizing national content in a scenario like, say, the Smithsonian, and they're really just digitizing analog formats. They're recording it with the correct metadata so that later that metadata can be searched and it can be used to have a really good sort of user responsive search experience. You know, directly translating those, you know, is a big job, and it's not that only one group will be talking to it. So we see that from, you know, broadcast. We see it from encoders, digital right management solutions that need to be able to plug into it, digitizing old books. If you see sort of the MAM space, media asset management, you know, these tools all need to plug into it. There are different groups that need to be working with it. So that actually needs to be a layer that can scale across an organization on the back end, just the same way that it scales for users on the front end. So that means also honoring things like authentication, LDAP backend, integrating seamlessly with Active Directory, and, you know, being able to function in, say, a Microsoft Office environment as well as a high-performance Linux environment on the front. It's also really important.
Yeah, and a few things to point out. You know, for the back office functionality and interoperability, you know, it's really important that you look for, you know, support of standard storage protocols like NFS and SMB, and, you know, what kind of support your vendor provides. You know, if I could point to one area where we as an organization have continued to innovate this year, it really has been in supporting traditional protocols like NFS, specifically for these types of use cases. And that's something really important, because I think when people talk about object storage, you know, a lot of times if they've had experience with object storage, their mind goes directly to, oh, it's just a RESTful interface and I have to work with an API. And, you know, that's really not the case now in the object storage world. You know, most vendors have file system interfaces or support traditional storage protocols, but not all of them do that the same. You know, we do it in a way where you're able to still customize metadata and be able to distribute content effectively and access it from a different protocol. And we support all the major protocols, NFS, SMB, even the pseudo protocols like Amazon S3. So, you know, just wanted to point that out. Just because, you know, we may not be certified for your specific application, we'll still be able to work with it through those standard protocols.
Yeah, that's a really good point. And in many cases, we've implemented those especially with scalability in mind, and especially what's important to look for too is that solutions will use their own unified namespace. So even if you're talking NFS on the back end to the object store, those resources, you can find them at the same URI path. So it's another way that sort of implementing things like NFS, you can either integrate legacy applications or applications that just want to talk, for instance, NFS, you can plug those right in. By the same token, going into a Microsoft environment and doing CIFs and honoring things like Active Directory, and having a system that's mature and has all those hooks in place can deliver the kind of privacy, authentication, authorization that you need in kind of a modern corporate environment, as well as a user-generated sort of more internet environment.
Yeah, and that's a good segue to the next slide is getting into use cases. Instead of diving deep into the actual frameworks and architectures for these use cases, we're just going to talk through a lot of them. And you've been talking a lot about social and user-generated content, and we did have some feedback from the audience that they're storing photos, and that's ideal for the first section there. So do you want to talk briefly about what we do in the social and user-generated content space, Ryan, and some of our customers that have gotten benefit?
Yeah, I mean, I think social is just, we've spoken to a few of these points, but I think, in social in general, the important thing is really low latency, working with mobile, working with many concurrent users, working fast enough for things like thumbnails, and also, we haven't spoken too much about this, but Swarm software is, you can run it on x86 hardware in general. So we've had people in social in particular provision clusters that are fully, SSD, or, fully, you can think of them as fully caching clusters because they wanted to hit, certain performance targets, and they had very specific configurations in mind. So that really lets you dial in the performance that you need. You may choose to have a series of servers that are loaded up with SSDs to hit one class of content, and you might have a set of servers that are more cheap and deep for really long tail content and things like video that are going to fill up more space. I think those are probably the biggest sort of value add hits for the social space. Looking into it, I mean, go ahead.
Well, and to add to that, on the other end, the organization that had SSDs, they had their other boxes with 7,200 RPM drives, real economical drives. And, they're able to really balance the price performance mix because object storage in general is highly tunable. It's really reliant on the hardware that you install it on. So, that was a good example. And, one organization that we don't have up here is a very large European retailer. And it's a team of developers who found themselves in charge of storage infrastructure. We're seeing that over and over again. Now in this web-based world, social world, mobile world, a lot of times the developers are in charge of the infrastructure. And, a lot of times they go to cloud-based infrastructure, but we all know after time, the cloud-based or cloud services costs compound. So there's always a time within an organization, if it's successful, that they bring operations back in-house because it's just more economical. For this team specifically, they really benefited from some of the data management functionality that's included or just standard in Swarm. So they have a seasonal business, and they upload photos for a particular season. Now, they don't want to store those photos in perpetuity, but they also don't want to have to go back and delete them manually when the season is over. So they just set a lifecycle policy to automatically delete those images after the season is done. That way, they don't have to worry about data management. The software takes care of that for them. All they have to worry about is, making sure their application is responsive, and enhancing the features of their application. So, that's one of the ways, I know we talk about storage and access a lot, but data management is a big component here too. Not sure if you have anything to add to that, Ryan, but.
I mean, I think that's a great introduction into, or it's really just pointing out, having policy management features, even at the content level, are extremely helpful. And, one of the ways that we do it in particular is metadata-driven policy management. And we have mechanisms in place to make that really easily facilitated in HTTP. So you have things like what we would call a life point that would really just specify, hey, here's content that is not deletable for some number of years. Here's content that should actually expire after some time. And the actual HTTP payload, which includes a header, which is the place where metadata is kept, already has a place for that information. So that information doesn't have to be held in any external system. Doesn't have to require another application that runs on another database. It can be contained in the objects themselves, and the storage infrastructure can act on those rules. So I think that's a great point.
Yeah, and it frees up your application resources to focus on functionality and features versus, the mundane task of actually managing data, which I think is really important to developers. Can you walk people through the streaming media use cases that we have?
Yeah, so in general, the streaming media generally depend on some video on-demand server or some streaming server up front, but then the key element is having a scalable backend for that server to talk to. So a scalable backend that already speaks HTTP, a scalable backend whose size can be really increased, double, triple to standard hardware, and they can take advantage of things like erasure coding to keep the total raw capacity really under control while protecting data with very good sort of nines of protection. So let's say you have a petabyte of content. Well, if you're keeping 3 replicas of that petabyte, all of a sudden you have 3 petabytes of data, and the extra 2 petabytes really hurts, right? If you're doing something like an erasure coding with something like a 15 parts to a 3 parts of parity strategy, then your raw to usable ratio is much better, and your petabyte of data might end up being something like 1.2 petabytes or 1.3 petabytes. So it's actually a very efficient way to store very large amounts of money, and that's especially important in the video content space. Also, being able to support range reads while still doing erasure coding is a non-trivial effort, and it's something that Swarm in particular is very good at. So I think that's another place where object storage in general and Swarm storage in particular is an ideal fit, and that's been important in these cases that are cited here, as well as others that aren't cited here.
Yeah, and I think to add a little business speak to the discussion, what Ryan pointed out is also important for some regulations that we have, especially here in the U.S. We have the Digital Millennium Copyright Act, and that specifies that you need to keep 3 copies of something that you take a recording of for a specific period of time. And then, you can go ahead and drop down to a more efficient method of protection. So with functionality inherent, at least in our object storage and Swarm object storage, you're able to automatically set those policies in place. So you can set 3 replicas for the first 24 hours, 48 hours, whatever you're trying to achieve, and then drop down to an erasure coding scheme. So just from an overall storage footprint perspective, let's go over what that means. 3 replicas is obviously 300% more footprint in your data center from a storage perspective. But from an erasure coding scheme, you can get an equivalent level of protection for that specific file at just 40% overhead. So right there, you're saving 160% in just overall data center footprint, and you have the same level of protection, and it's completely automated and set for you. So that's one of the ways that the infrastructure you choose for your video helps you abide by certain regulations or try to meet your business requirements. And Ryan also touched upon digital rights management. From an object storage perspective, there's always a place for content delivery networks, for content that's being accessed, maybe thousands of times, tens of thousands of times a minute. Very high load. But for those of you in the media and entertainment space, you know how expensive CDNs are. Object storage is great as origin storage, and also to provide delivery for long-tail content. So now the vast majority of content and videos that are shared over the internet now are back catalog. It's not always the popular stuff. You need to offer a whole breadth of content, and object storage is ideal for that. That way you can really reduce your reliance on CDNs, stand up an object storage solution with your own data center, and provide your own origin storage services in a way that's really easy to manage. So those are two ways that, oh, go ahead.
Yeah, no, so I think long-tail content's a great segue into long-term archive too, especially because what we've seen in working with national archives in general is people, they have the long-tail content, or they have a very large collection of content, and they need rock-solid protection, so they need all their nines. They need the storage footprint to be efficient, so they need erasure coding. But they also need low latency access to that long tail of content, because let's say someone goes into the library and they're using the user portal into this content. By the way, it's already HTTP, so it's the right protocol, doesn't need a translation, but they want millisecond access into that long tail of content. And that's important. I mean, people don't want to be waiting 10 seconds, 20 seconds, 30 seconds for things to come back that, say might be on something like tape. People still want user responsive and user meaningful amounts of time to access long tail content, even if that content maybe hasn't been accessed by a user in a month.
Yeah, absolutely. And a lot of the times their requirements to the funding they get, they need to keep this online and accessible as part of the funding to keep these cultural archives or just general archives in place. And that's really important as everything's connected now. We live in a connected world. And Ryan did touch upon power conservation and Darchive. Again, best of breed object storage solutions out there will have some form of power efficiency mechanism or feature. The ability to spin down drives in a way that'll save significant amount in cost, power, and cooling over time.
Absolutely.
I mean, anything more to add to any of these use cases, Ryan? Just from a high level?
We could dive into each one of them for a complete hour. It's really difficult to pick out the things that make the most sense. I would just say too, if anybody has specific interest in any of these use cases, you can ask questions now and we can get to them, but you can also contact us with our contact info that you'll have, and we would be really happy to dive into those use cases in more depth. But I think that's probably a good level to keep them for now.
Yeah, and I'm going to go ahead and push out the next question is, would you like a consultation with one of our object storage specialists, someone of the caliber of Orion, who can really come in and answer your questions? You can obviously ask questions now. We have already started getting questions from the audience. So when you talk about low latency, this is the first question, Ryan. When you talk about low latency, are you referring to end latency or just a storage latency? How do you reduce storage latency in particular?
Okay, so end-to-end latency would include really the entire infrastructure, and it would include the, say, Nginx or Varnish or Big IP, F5 in front, as well as, it might include the front-end CDN. So, we're generally talking about storage latency, and in particular, it's a great question, and in particular in Swarm, the way that we handle it is we actually have the indexed location on disk of all content in RAM. So we can find, we can find that location without doing disk seeks. We can find that location without reading different parts of disks to find our way through inode paths, through hierarchical file systems. It's one large flat address space, and we can find the location of the objects in RAM, and we can go straight to those objects, and we can start serving them. Generally, single-digit millisecond response times. And so, that is sort of storage-level latency that I would say. Yeah, go ahead.
Well, I was going to go back to the diagram just so you can point out, in this scenario, we did affect more than just storage latency when we removed, the database and some of the access applications. So we were able to collapse, the IT stack, and now there's just this one tier of infrastructure to scale.
Yeah, absolutely true. So compared to a before architecture where, say, a request might actually need to be routed out to databases or go to legacy file systems, collapsing those layers certainly helps the latency. But then just in a Swarm context, getting to the objects is actually something those are questions you can answer without seeking to a disk as well. So very good point. Very good point, Adrian.
Yeah, so we're going to go, we answered that one. There's a person who said that they can't hear audio. After the webinar, we'll go ahead and follow up with you. I believe it may be the same person who answered the question, but we'll make sure that you get the response. We have another question. It says, do you support any specific storing caching technology using flash and or RAM?
Yeah, we'll fully utilize the flash and RAM that you want to deploy in x86 servers or that we deploy in x86 servers. So I think the answer is really yes, and all of them. And we've had, like I said, we've had customers and partners, fully load machines using SSDs, using non-volatile, to meet the performance and price characteristics they need. So that's a great question. And yes, we absolutely support it and utilize it fully.
Yeah, and I guess that's a differentiation that we can point out. Our software actually runs from RAM. The software isn't installed on hard disk. So the hard drive technology is really meant for your content, and there's a very light journal. So we do leverage the RAM to deliver content and organize and I guess direct all the traffic within our system. And that is, it's a bit different than how others do it on the market. So inherently we utilize RAM, and we utilize the RAM and flash speed within our software.
Absolutely correct.
Yeah. And with that, there's also storage caching technologies, but you mentioned Nginx and Varnish and other type of caching technologies. I mean, what is kind of the development effort into those types of technologies?
I mean, they will want to be generally deployed on the front end tier. There's generally a DMZ kind of layer, but setting up those layers is really the same as it would be otherwise. So there really is no special. There's really no special thing that you have to do to integrate the two. They're already HTTP. That's one of the nice things about them. In some cases, there'll be things like forwarding rules and, you know, rules where, you know, certain kinds of operations would be forwarded and certain kinds of operations wouldn't. So for instance, you can configure the object storage cluster to both accept and not accept certain HTTP requests, like a delete, for instance. And then with the front end infrastructure, or the front end, you know, Nginx or Squid or Varnish, just really setting up the appropriate forwarding rules is the only thing that's needed.
We have another question that came in. Is a single millisecond response at figure time using non-flash SSD x86 machines? So, you know, what kind of, I guess the question said another way, what kind of performance can you expect from non-flash SSD?
Yeah, it wouldn't be a single millisecond response time. I mean, I'd say generally it will be some, it'll be a histogram with the median somewhere in the single-digit milliseconds response times. So I wouldn't want to give the impression it's always a single millisecond response time, but I would say it's a histogram with a median response time in the single millisecond range. And that is using non-flash SSD machines.
Yeah, and there's a lot of variables to consider too, right? Especially where the client is, where they're accessing from, and how far they are from the source. You know, it really depends on where you're measuring overall latency within the content delivery path. You know, what we find, we utilize the performance of the underlying hardware very efficiently. I mean, would you want to put some sort of
completely
percentage on that, Ryan?
In fact, yeah, I mean, completely efficiently. In fact, you know, our testing methodology and our testing focus is always to fully utilize the hardware. You know, fully realize the performance potential of the hardware and leave no limiting factors in the delivery of content.
So leave no bit, byte, or processing unit behind.
Unoptimized. That's right.
Exactly. But even, you know, I guess furthermore, it's just we're not going to change the laws of physics with our software, right? I mean, it's all based upon the hardware that you install it on. We're not going to go faster than the hardware can go. I think that's the point to make, and that's why you really have to optimize for your specific use case. But as far as efficiency, you know, as Ryan said, we're probably one of the most efficient solutions on the market from a hardware utilization perspective. We'll give a few more seconds for any other questions to come in. Ryan, anything else to add while we're waiting?
I think that's it. I think that was a good discussion of, at a high level, why object storage in general and Swarm in particular is a great fit. And we'll really look forward to connecting with anyone that wants to connect with us for a deeper dive.
Yeah, and as Ryan mentioned, you know, this is a very broad industry, M&E, content delivery, content distribution. There's a lot of use cases underneath, or I should say industries and vertical focus underneath the broad umbrella of this industry. So if you do want us to dive down deep into your particular use case, please feel free to reach out to us. You have both of our contact info there. You know, our email is open to you if you have any questions. And with that, I will say thank you, everyone, audience, for hanging with us, and thank you for your time today. And Ryan, as always, thank you for your time.
Thanks, Adrian. Thanks, everyone, for joining us.
All right, thanks. And by the way, we have some great resources on Caringo.com. Just go to our resources section. If you do have any questions, you can send them also to info@Caringo.com if you have any general questions. If you do happen to be at Streaming Media West next week, I'll be presenting there. We'll have a booth there. Stop by and say hi to us. We'll also be at NAB in April. I know that's quite a bit out, but if you are going to be at NAB, we'll also be there, and we'd love to meet you. So with that, I'll say have a great rest of your day or rest of your evening, and this concludes our webinar. Thanks, everyone.